Hello everyone, my name is Varun. So today I'm going to explain about bisection method and its application in control systems. So bisection method is generally used to find the root of the equation, and in optimization point of view, we can use this bisection method to find out the minimum or maximum value of a function. So the basic idea is we have to take an interval a comma b and we have to reduce this interval until we get the minimum point or the root of the equation. So this is the main concept behind bisection method. So how we do is we have to find out the midpoint. If the midpoint is greater than or less than the function value at one of the endpoints, it updates the interval by replacing the endpoint. So we have taken this simple case here. Here you can see we have found out the function value is positive at this point and negative at this one. We have to take an interval and find out 2 points such that the function value is negative at one point and the function value is positive. So definitely the root will lie between these 2 points. So gradually we have to reduce this interval and ultimately we will reach a point where we'll get the root of the equation. So we have to do multiple iterations until we get this point. Similarly, in optimization point of view, we have to take 2 points such that one point slope is negative and one point is positive. And we will find the value at the midpoint. If it is positive, then the new interval will be from this point to this point. And similarly, we have to reduce this interval until we get this point, the minimum point. So that is ultimately the f dash of x is 0, which is the thing we have been learning from the lower classes. So we have to take 2 points such that one point is minimum and one point slope is maximum, like positive, and we have to reduce the interval until we get that f dash of x is 0. So here is a simple illustration that I've taken. I've taken a function x square plus 54 by x and a simple interval 2 comma 5. So here I found out that the function derivative value f dash of x is opposite sign. So definitely the minimum value will be lying between these 2 points. So I found out that's the opposite sign. So we will reduce the interval if it is 2.5. The midpoint is 3.5, and if the slope is positive at 3.5, then the new interval will be 2 comma 3.5. And if the slope is negative, then the new interval will be 3.5 comma 5. So like that we have to reduce the interval and we have to reach the point until the slope is 0. So in the above example, I found out that after 10 iterations, I found out the solution is 3. So you can observe that it's taking a long time, 10 iterations. So we'll discuss that later. So this is the main point. What is the real life applications of bisection method? So in computer science, in sorting and searching, where in sorting, if the sequence is in an ordered way, like 2, 3, 4, 7, in that way, and in Huffman coding also, if we ask you to find out the number in which is in this ordered list. So similarly, we can take that in binary search. What we do is we'll find out the midpoint, and if number is lying between this point, the midpoint and the highest range, we will take the new range. Similarly for the lower range, so in that you can reduce the time complexity. So this is how we use binary search in uh, for bisection method. Similarly in physics, in order to solve the Schrodinger equation, we have to find the roots of the equation. So these Schrodinger equations are very of a high degree, so you cannot find out the double derivatives. So what we do is we take a simple interval and we will find out the value of the root of the equation using bisection method. The similar way in which we did the above. So in AC point of view also, in circuit analysis, if we want to find out the resistor value or the capacitance value, we will take a certain interval and until it meets a certain specification, we have to repeat this process and we will get the resistor value or the capacitor value. So what are the applications in control systems? So this is the application in the EC point of view. So what we'll do is we know that the characteristic equation f of x by g of x. Here g of x is equal to 0 is the characteristic equation. So what we'll do is we will find out the poles of the system, and if then the poles of the system will definitely define the stability of the system. So what we'll do is if the poles lie in the left half of the plane, then we know that it's stable, and if it lies in the right half of the plane, then it is not stable. So using bisection method, we can reduce the interval, and if we found out the root is negative, then definitely the system is stable. And if the systems are right in the right half of the plane, then the system is not stable. So this is a simple Python code. We will import numpy as np from the Python library. So given x cube minus 4x squared plus 3x plus 1 as a characteristic equation. So what we'll do is we will find out the midpoint, and if the midpoint is greater than 0, we will proceed further. So if the midpoint is greater than 0, uh, we will proceed further. Then if it's 0, then we have directly found that it is the root of the equation, but it's not in the every case. So we have to take other cases also, like if elif f of c is, so if it's not satisfying this, then we have to go to the elif. If the slope here we have taken the function value is negative, that means one point is positive, one of the function value is positive, one of the function value is negative. So definitely the root will lie between these 2 points. So then we have to find out the function. We have to return this process a plus b by 2, and we have to repeat this process until we get that point. So this we will write in a function. So I've taken an example for this root 2 like this. In these intervals we'll find out, and this will print the roots. So what are the results of this? So I've taken a function g of x cube minus 5x squared plus 8x minus 4, and these are the search intervals minus 2 comma 0 0 comma 1.5 1.5 comma 3. So these are the characteristic equations, and we will find out the roots of this equation using bisection method. One of the value of the range should be positive, and one of the value will be negative. So definitely then the root will lie between these 2 points, and we will be able to find out the root of the equation. So if the root of the equation is negative, then the system is not stable, and if the root of the system is positive, then the system is stable. Here we are taken with a tolerance of 0.01, which is very less. So this is how I found out the root values using the above code. I found out that root 1 is -1. So what we can say, it is a stable for that equation, stable range, and root 2 is positive. So this is not stable because it lies in the right half of the plane. Root 3 is positive in the right half of the S plane, so it's not stable. So this is how we are implementing bisection method for control systems in easy point of view. So this is a simple application in control systems. Thank you.